we'll be doing as a tester, right? So, and they are what we'll be doing today are test levels. We'll be discussing what test level is, different kind of test level, right? And what they mean, who does, each one, right? So the next one is test types. We'll be looking at different types of testing, types of tests that will carry out, right? And we'll see what they are, what they mean. So we'll be discussing about bugs. And I know in the past we've talked about bug, we've talked about defect, we've talked about error, and then failure. Today we'll be talking about bugs. We'll be going into great detail on bugs, and then we'll talk about defect life cycle. We'll look at the defect, what happens when you find a defect, which obviously you can say it's a bug. We'll look at what that means, how the life cycle from the point you find it up until the point that it's been closed, right? So, and then the topic that we'll be covering today is, like I've mentioned before, test levels, right? The second one is test types. What is bug? We'll be looking at what a bug is, what is a bug. Then we'll be talking about the components of bugs. What are the components of bugs? We'll be looking into that. And then we'll also talk about defect life cycle, right? We'll also look at defect priority, right, and defect severity. So I believe that most of the things we'll be talking today will be, we're diving into detail of what we've discussed before, because of most of the things that we'll be mentioning today, we must have mentioned it in one way or the other in our last two classes. So that is why I urge everyone to pay attention. The videos are up. Feel free to go watch the video. Feel free to read about any of this thing that we're mentioning, because we'll keep hearing them. You keep hearing bug all through your career as a tester. You keep hearing types of testing all through your career as a tester. You keep, following defect life cycle. You keep talking about defect priority, defect severity. Yesterday, I made reference about a time I was testing a bug or a defect that is of lower priority, and the one with high priority came. I have to leave it and then start testing the one of higher priority. So all the things. So you keep, whenever you raise a bug, when you're talking about components of bugs, whenever you raise a bug, you need to know all the components, of a bug. You need to include it when you're raising a bug. So everything we'll be doing today are really, really important. So pay attention. Raise your hand if you have any question, right, and ask your question, and I will answer it. So it will be a very smooth one today, right? Don't think it's that long as the past few days, but it's very important you pay attention, right? So let's dive straight into it, right? So the first one is levels of testing, right? Level of testing. So I also want to tell you that software testing involves various levels of testing, right? To ensure the quality and reliability of a software product. We'll keep talking about ensuring quality and reliability. I've mentioned this more than 5-6 times. That once we are testing, we are ensuring quality and reliability of that software, right? So, like I said, software testing involves various level of testing. And why? What does it do? It ensures the reliability and quality of that particular software, right? So each testing level focus on different aspects of software and contribute to overall testing process. So as you can see here on the slide, we'll have different level. You can see the unit testing, right? You can see the integration testing. You can see the system testing. You can see acceptance testing, right? These are different level of testing. These are different levels of testing, right? So now let's look at the unit testing, right? Yeah. So let's look at the unit testing. So the unit testing focus on the individual components, units. You focus on the individual components, right, of any part of software, right? So this kind of testing, right, this level of testing, right, focus on the smallest units of that software application. Majorly, it's being done around code, right? So the essence is to test the individual function or method. Are you getting my point now? So you focus on the individual component, individual function, individual method, right? And to ensure and the purpose is to ensure that all these individual components, all these individual functions are working as intended. Let's take example a login page of a Facebook, right? So now what happens when a developer is developing this software, right? They do it component by component. So what the developer do is to code, right? Develop the login page, the login functionality, right? Once that developer developed that login functionality, right, it's written as a code. They are not looking at it from the UI point of view of things, right? They are not seeing it. They are not seeing the interface, right? So they've written the code. So what you do is that they test that particular component. If they've written any function, they test it. Right? So after testing it, if it is fine, then they go to the next one. They will, like I said, they've developed, right, the login function and that login fields, right, where you have your username and your password. They've developed that. Once they've developed that, they will test it to ensure that users are able to impute their username. Users are able to impute their password. They will test that. If that is functioning as expected, right? And that what is the kind of testing that they do? The kind of testing they do is unit testing. So they are testing those individual components, those units, right? So once they are done testing that, they go and now develop the submit button. Once you enter your username and your password, the next one is you to click on submit. So they click on that submit, right? They develop the submit, right? And then they test it to ensure that that submit button is working, right? So once they've done that, the next thing is that, and they've done that, once they enter their field, their login details, and they click on the submit button, it's clicking, right? They've tested that is functioning. Like I said, the kind of testing they do at that level is what? Unit testing. The next thing is to go and develop the landing page. When you've clicked on, when you want to log into Facebook, right? You've entered your username, you've entered your password, you click on submit button, then you will land to a page, right? And that page is you. You have logged in, right, as a user on Facebook, right? So once you have done that, what the developer does is to now go and create that login, that landing page. Once they've created that landing page, they will also test that landing page, that when a user enter their username, their password, and click on submit button, they land on that landing page, which happens to be on their account. Right? That sort of testing, or that level of testing, is known as unit testing. And developers are those that does unit testing. We testers would not do unit testing, right? So the developers does that unit testing at the level of, and what they do is testing those individual components, testing those smaller units of their code, right? And how do they do it? Some of them, they do it manually. Some of them, they automate it. They write code to check their components, right, of what they have done. So that is it for unit testing. That is it for unit testing, right? So the next one is integration testing. We'll go into integration testing, right? And what is integration testing? Integration testing validate the interaction between two or more components, right? Like I've mentioned now, right? You have the login, right? You have navigating to URL, like when you enter the URL, let's say you want to go have access to Facebook, and you've typed in www or https.facebook.com, right? And you click on it, you are on the landing page, right? Or the home page. So once you now enter your username and password, it will navigate you to another page, right? So those are integrated components. So they navigating to the URL, integrate it with the login field, and then integrate it with the landing page. And then they integrate it with, let's say you click on your profile will open. So all these are different components, right? But they have integrated it together. So what integration testing does is to ensure that once you are moving from, when you are testing, when you are doing integration testing, you are now testing and validating that you can move from from navigating to URL to the login page. You can move from login page to your landing page. So that's what integration testing does. Like I said, it tests the integrated components, right? It tests integrated components. It identifies interface between components and tests their interaction. It ensures that data flows correctly across different parts of the system, right? So I've used example when you are navigating to URL and then you log in, then you navigate to your landing page, right? So they need to link it together. When the developers are testing, when the developers are actually developing this, they create all these components individually and they link it together, right? So when you are now testing all of them in combination, what you are doing is what? Integration testing, right? So now, who does, like I said, unit testing are done by developers, but integration testing are usually done by what? Testers. We do integration testing, right? So that is it for integration test. And then we'll move over to system testing. System testing. As you can see, with system testing, system testing tests the entire system, right? System testing does what? Tests the entire system, right? So now, when developers have written the code, right, when they are doing their development, they write code, right? They link the whole system together. Sometimes they move from one, sometimes they move, like, for example, when you have a particular system that does one thing, right? You can register and then you pay your you enter your card detail and everything, and then it takes you to a different system where you go, let's say, for example, the Klarna, right? So now when you are doing system testing, you are looking at navigating from one place to another. You are testing the entire system, testing on how they interact, how they integrate, right? That is what you do when you are doing system testing. You evaluate the complete and integrated software product to ensure it meets specific requirements, right? So the activity you perform during this time is that you test the entire system functionality, right? You test that, yeah, this system is functioning correctly. You test that this system is performing very well. You test the security, right? That, yeah, it's not broken in any way, right? And then you do an end-to-end testing. You start from the beginning, from the time you log into the password, enter your URL, up until the time you check out, the time you purchase your product, and everything that has to do with that system, right? And of course, we testers do the what system testing, right? We testers do the system testing. So the next one we'll have is acceptance testing. Acceptance testing, right? So we'll have acceptance testing. And what acceptance testing is to confirm that the software meets users' requirements and is ready for deployment. Right? So you are not testing that, yeah, this can be accepted by, the users, that, yeah, it has met users' requirements, that users are able to use it, So how do you do this? You are now doing the testing based on the end user's point of view, right? You are doing it based on the end user point of view. So sometimes in an organization, you have a tester doing UAT testing, right? You see, say acceptance testing can also be called UAT, which is user acceptance testing, right? So now this acceptance testing also can include, let me admit. So yeah, so this acceptance testing can include, there are different ways this acceptance testing can be, carried out, and they include alpha testing. So alpha testing is the kind of testing that we'll do at the beginning, right? So testing within the organization by dedicated testing team, right? So alpha tests I've mentioned about acceptance testing, and I've told you that sometimes, like in most organizations, you find out that the PO or the business analyst is doing UAT testing. Sometimes they have a dedicated software tester who does acceptance testing. Sometimes they have to give it to the end user, right? Let's say an organization is have their own IT team, right? So once they develop a particular functionality, they give it to the internal stakeholders to test. So what they are doing is a kind of acceptance testing as well, right? Like I said, acceptance testing is what conducted by the end user, right? Conducted by the end user, and it includes alpha testing. Acceptance testing includes what? Alpha testing, beta testing, and what? User acceptance testing, right? So what is alpha testing? I want to go into brief detail about the ones that I've mentioned. What is alpha testing? Alpha testing is a type of testing that is done within the organization by a dedicated testing team. So once a team like my current company, so once a particular software has gone through, the developer has done the own kind of testing, right? The QA has have done my own testing, right? It has done during the user acceptance testing. So what do we do? So we'll select some end users, right, to do the testing. We'll select some end users to do the testing, right? Yes, Vincent is trying to join. I've accepted him. Yeah, so let him try to join again. So yes, so I will select some people. They will do the acceptance testing, the alpha, which is the first testing that you do, right? So now, I also mentioned about beta testing. Beta testing is performed by a selected group of external users in a real world environment. Like I've said, that alpha testing is done within the organization, but beta testing is done by a selected group of external users, right? They will conduct the beta testing. Then, like I said, we'll have the user acceptance testing, which is under acceptance testing, right? So this is the final testing by the end user to ensure that the software meets business requirements. So these are the level of testing. Like I said, we'll have different level of testing. You have the unit testing conducted by the developer. We'll have integration testing, where you are testing the integrated components of that software. We'll have the system testing, where you test the entire system. Then acceptance testing, which includes alpha testing, beta testing, and user acceptance testing, right? So now we have note the different I am talking about I'm talking about level of testing, because you might try to confuse it, or it might be a bit confusing if you don't know the difference. Now we've talked about level of testing. So after level of testing, we'll be talking about types of testing. Level of testing and types of testing are not the same, right? We'll be talking about types of testing. Yes, types of testing, right? So as you can see, we'll have different types of testing, and they include functional testing, non-functional testing, compatibility testing, and security testing, right? Types of testing. We just discussed level of testing. Now we are talking about types of testing, right? So, and I've mentioned that types of testing are functional testing, non-functional testing, compatibility testing, and security testing. So now let's look at them one after the other. Let's look at functional testing. All right. So what does functional testing means? So with functional testing, the tester verifies that the software functions as expected and according to specification. Functional, right? As the name implies, functional. You are testing that the software functions as expected, right? And under functional testing, we have different subtypes that we've mentioned, right? Which include unit testing. I've mentioned unit testing under the level of testing, right? So under functional testing, you perform the level of testing that is being performed includes unit testing, which I've mentioned before, testing the individual unit or component of that particular software, right? You also do integration testing under functional testing, right? So, and I've mentioned before, with integration testing, you are testing the interaction between integrated components or system, right? And then you have system testing, evaluating the complete system functionality under functional testing, right? And then you also have acceptance testing, where you are confirming that the software meets users' requirements, right? So after that, we'll now go to non-functional testing. Notice we'll have functional testing and non-functional testing, right? So under non-functional testing, we as testers, we are testing the non-functional aspects of that software, right? You're no longer testing, okay, the functionalities. You are now testing the non-functionality. And the example of that is you are now testing the aspect, you are now testing the performance. Notice you are not testing the performance. With functional testing, you are testing the functionalities, right? But now for non-functional testing, you are testing the performance, how that system is performing, right? How that system is performing, right? You are testing the usability, right? How, when users are using it, how are they able to navigate around the website, right? So you are testing the security of that software. Is it secured enough? Right? If you put in your details there, would hackers be able to extract your data, your personal data? You're testing those functionality. You're testing how easy it is for hackers to or malicious online malicious users to extract your data from there, right? So now you are also testing reliability. You are also testing reliability, how reliable that particular software is. The information you're getting on that software, is it correct or not? And under non-functional testing, these are the kind of testing you perform, right? Example of the testing you perform is performance testing, right? So I've mentioned it, performance testing. So performance testing evaluates system responsiveness, how responsive the system is, right? It also tests the stability. Let's say if in our first class I've mentioned like some company, once they are opening a a job, once they have a job opening, right? And they've announced over time that yes, we're opening our website for applicants to start submitting the application on so day. So when it gets to that day, you see rush. A lot of people are going to that website to submit their application. They are going to that website to submit their resume, their CV, filling out the application form, right? So before that, if that organization has not done non-functional testing to see how their system will perform, right? When a lot of people has come, when greater number of people, let's say 1,000, 2,000 people are using their website at the same time, right? If you haven't tested it and satisfied that yet, our system is stable enough, right, to respond to over 2,000, over 3,000, over 5,000, over 1 million people attending our website at the same time, right? If they haven't done that, their system might break down. That's why you find out sometimes they say, oh, yeah, the system is not available at the moment, or you're trying to submit an application, the system is malfunctioning, it's no longer stable, right? So these are the kind of testing we do under non-functional testing. We also have security testing, and we have what we'll have stability testing, and we'll have scalability testing, right? So the next one is usability testing. Usability testing, right? I've mentioned before that usability testing has to do with how easier or how user-friendly, your software is. Because there are some software you will go, even without having gone through that software before, it's easy to navigate around. Let's say, for example, and the reason why this is important is that you want your user to easily go on your website, see what your website is or your business is all about, subscribe to whatever business you are offering, right? And be able to buy your products, right? If you are selling product, let's say you have an e-commerce website where you sell certain product, you want your website to be as easy as possible for users to come in and be able to see whatever they are looking for and then purchase the product you're selling, right? That is where usability comes in, right? So we also have security testing, which deals with identifying vulnerabilities and ensuring data protection. Because obviously you want your website, your software to be secured, right? You don't want your user to put in there. There was a time for those of us that use this one of these will have something express, right? So where you used to check your credit, where you check your credit score, right? So there was a time it was attacked, and then people's information were stolen and sold, right? So these are not the things you want for your software. These are not the things you want for your website. You do not want your user that registered, they are putting their personal identifiable information, right? They're putting in their credit card. You do not want that website. You do not want that website to be vulnerable to attackers, right? You want to ensure that it is secured. So, and that is what security testing help us to achieve, right? That is what security testing help us to achieve. So we'll come into each of them, right? In later lecture, we'll come into each of them in great details, right? So we'll have reliability testing as well. We'll have reliability testing. And what does reliability testing? It does. Reliability testing help us to assess the software stability and consistency, right? So you don't want to log in with a particular. I've mentioned this in our first class. So, like I said, most of the thing I'll be seeing, I will be retreating it. I'll be retreating it. That is how they are intertwined. That is how they all linked with each other, right? If you recall, I've mentioned when you are logging into a particular website, let's say Facebook, for example, is not reliable, right? So each time you've made the first attempt to log into your website, right? To log into Facebook, you've entered your username, you entered your password, and they are both correct. You've logged in, right? You've done everything you want to do. You've chat with friends and watch memes and things, and then you've gone out, and then you want to log in again to do something else, and you are not able to log in, even with your correct username and password. You're not able to log out. You're not able to log in, right? That becomes a problem. That becomes a huge problem, right? So that is why every software needs to be what? Stable and consistent. Let's say, for example, I know most of us will have bank accounts, right? So when you've logged into your mobile app, maybe you're using your mobile app, you're doing online banking. So you log in, you've done transaction, and then you want to perform another transaction, and you're trying to log in, and it's not letting you. You will panic. You'll panic. And if that continues, you wouldn't want to use that particular software again. You wouldn't want to use that particular bank again, or whatever product they're offering, right? So that is it with non-functional testing, right? So the next one we'll have is compatibility. Compatibility testing. We want to go into compatibility testing. And what does compatibility testing mean? Compatibility testing ensure that softwares function correctly on different platforms, right? Compatibility. Most of them, you can even tell what it means as the name implies. You want to ensure that that piece of software is compatible with different browsers, different device, right? So there are some applications, right, that you can open it with Chrome, but you can open it with Firefox. You will say, oh, this particular software is not compatible with Firefox. Some of them are desktop, you can't do it online, right? Some of them you can't even open that particular software on your mobile device or on your tablets. Some of them are compatible with Android, and they are not compatible with iOS, which is your Apple, right? So when a company has built a website, and The requirement says that this website, this software should be compatible with both Android and iOS, and it should be compatible with all browsers. Right? So when you are testing this particular software, when you are doing compatibility testing, right, you are opening these websites, you are testing this website with your mobile device, your Android a mobile device. You will test this same software application with your iOS device. You will test it on your tablet, iOS tablet. You will test it on your Android tablet. You will test it on your, laptop, your desktop, right? You test it with different browsers. Your Chrome browser. You will test it on your Edge browser. You will test it on Safari. You will test it on Firefox and every other browser. You want to ensure they are compatible with all these different devices, right? You want to ensure that they work as expected on all these different browsers and different devices. That's what compatibility testing is all about, right? And what are the kind of testing we'll do? We'll do browser compatibility, like I've mentioned. You do what? Browser compatibility, which is assessing the compatibility across different web browsers. I've mentioned most of the web browser. I've mentioned Chrome web browser. I've mentioned Edge. I've mentioned Firefox, right? I've mentioned Safari and so many others, right? You can do across devices as well. I have done compatibility testing where I have to test using different browsers, right? I have to test using different devices. I'll be testing on Android, I'll be testing on iOS, I'll be testing on different devices. These are compatibility testing that you are performing, right? So now, moving on to the next one, which is what? Security testing. Like I've mentioned before, security testing is the kind of testing we do to identify vulnerabilities around our softwares, around our website, around our applications, and to ensure that any data that the end user are inputting are protected. Right? And what are the ways or the type of testing we'll do under this security test? We'll have vulnerability scanning, right? So this is when you use an automated test to assess for unknown vulnerabilities, because there are some vulnerabilities we do not know, right? So if you're a security tester, you do vulnerability scanning on the website. So vulnerability scanning will come with the test results that comprises of all the tests and all the vulnerabilities on your website, where malicious attackers can have access. Let's say that your software, your login function, your login is not secured enough, right? So the vulnerability scanner will be able to identify it and tell you that, yeah, this is not secured enough. Your website is taking a weak password that not end user, that malicious attackers can easily guess. Right? That's why I know this will resonate with you. When you go into some websites, right, they will tell you that no, if you impute when you are setting your password and they're asking you for a strong password, it's for security reasons. They do not want you to go and enter 12345, and that will be your password, because attackers, right, hackers can easily guess it, right? That is security. That is security. So any website that ensures that you put in a very strong password, that are the security. These are the security measures. And let's say you are doing testing, and the requirement comes that once you enter a weak password, the system should be able to flag it and not accept a weak password, right? These are measures, security measures. You were testing that functionality. You ensure that the system only accepts strong password, combination of alphabets and numbers and special characters, right? And then another kind of security testing is penetration testing. Penetration testing. So what is penetration testing is all about? Penetration testing is when, right, penetration testers, you can call them pen testers, right? They are stimulating a real world attack. You know the way hackers would want to hack into your website, will want to hack into your Facebook account, will want to hack into your Gmail account, will want to hack into your bank account. So what penetration testers does is to stimulate this kind of testing, right? To try and get access to companies' websites, to try and get access to companies' mobile application, to try and get access to company um, softwares, right? To see if how possible, all right, or how easy it is for them to get. If they're able to get access into that software, that means that hackers can easily get access. But if they're not able to get access to the to the software, that means it will be difficult for hackers to get access. That is what security testing is all about, or pen testing is all about, right? So, that is what security testing is all about. So we'll go to the next slide. So now on this next slide, you can see we have about 16 different type of tests, and these are additional type of testing that we can do. Like as you can see, we have functional testing, right? Some of them are ones we've mentioned, some of them we've not mentioned it. So we can see functional testing which we've mentioned, which entails testing the functionalities, testing how it functions. So we've talked about the non-functional testing, where we'll talk about the assessing the non-functional aspect of it, such as conducting performance testing, usability testing, security testing, reliability testing. Or you can see unit testing, which is also a level of testing, right? And I've mentioned that it's testing the the smallest unit or component of that website. I've mentioned that it's done by developers, right? You've seen system testing, which is number 4, system testing, which involve testing all the system, right, of that particular software. We've done integration testing, how different components, right, interact. You have end-to-end testing, end-to-end testing. So end-to-end testing involves beginning to the end, right? You're testing it from one end to another end, right? Let's say you want to test prep measure, you want to test how interns can come in, register from the point of navigating to the website to the point of registration, for the point of purchasing the course, to the point of payment, either using card or Klarna. You test all these different scenarios from one end to another end, right? That is what end-to-end testing. We've done acceptance testing, where I told you that under acceptance testing, we'll have alpha testing, we'll have beta testing. Sometimes you call it alpha beta testing. Sometimes in an interview, they ask you some of these questions, right? What have you done functional testing? What are functional testing? Have you heard of alpha beta testing? I've told you alpha testing is done by the internal, selected internal members of the organization, whereas the beta testing is done after testing, alpha testing, which is done by outside user, the real world user, right? So, and then we'll have the UAT as well, which is user acceptance testing, right? Under acceptance testing. So we'll have smoke testing, right? And what is smoke testing? We haven't mentioned smoke testing before. So what is smoke testing? Smoke testing is quick assessment to determine if the software build is stable enough for further testing. So sometimes, depending on what approach your organization is using, sometimes once they have built something, they want you to go and eyeball it. They want you to go and look at it. They want you to do smoke testing. Smoke testing is that initial testing you would do, right? Just looking at it, oh, okay, yeah, this is good, this is good, this is good. It gives room for further testing, right? So after smoke testing, we'll have the security testing, which we have mentioned. We'll have sanity testing. So sanity testing has to do with checking again that when you have done, maybe you find bugs, those bugs are being fixed and everything is fine. Then you will sanity check. You will check again that nothing has been broken, everything is fine and working according to plan. That is when you are checking sanity. Right, you're making sure that everything is good, right? Then you talk about performance testing again. I've mentioned, we've talked about what performance testing is, which I say is you're evaluating the system responsiveness, the system stability, how stable the system is, and how scalable the system is as well. So also talk about regression testing. You'll be doing a lot of regression testing, right? You'll be doing a lot of regression testing. And let me elaborate on regression testing, right? So now, when you have raised a bug, right? When you have raised a bug or you found a defect, you've raised it, the developer has, has fixed that bug. You've retested that particular bug and everything is fine. So you now have to do another set of testing, test around all the components of that bug. Okay, let's say, for example, right, you are testing login. I usually use login because we'll log into websites every day. We'll log into our mobile application, different application that we use on our daily basis. So it's one that we're quite familiar with because we use them every day, right? So let's say you are trying to log in, right? Or you are testing a login functionality as a tester, right? Now, you've entered your username, it's working. You've entered your password, it's working. But when you click on submit or login, it's not clicking, right? You've raised that as a bug, right? The developer has fixed that. And when you come back, you click on the login, it's clicking, right? Now that bug is fixed. But you need to do a regression testing to test around that component, to ensure that you can still enter, because sometimes developers, because they are working with code, right? They don't see what we are seeing. What they see is their code, right? So sometimes they could go to fix that bug. So they will move the logic around, that login around. And sometimes you won't even be able, they fix that button. The button is clickable now, but you can't even enter your username or your password again, right? So that is where regression testing comes in, to ensure that every other function, every other functionality around that particular one that we have the developer has fixed and we have tested are working as it should, right? That is where regression testing comes in. Regression testing comes in, right? So the next one is alpha testing. We've mentioned that and I've illustrated that. The next one is beta testing. We'll have black box testing, black box testing. Black box testing. When you hear of black box, when you get into a room, let me give you a scenario. You get into a room that is black, is dark, right? You won't see anything, would you? No. Or you are peeping through a box that is black, you won't see anything, right? So bringing it back to software testing, right? And so when you are doing black box testing, right? So you are testing a software functionality without having knowledge of its internal code or logic. You do not know, you haven't seen the source code, you do not know all the logic that the developer has written around that code, around that software, and you are testing it. You've just gone in and you are testing it. That is what black box. You do not have any prior knowledge. You are testing the functionality of a software without any knowledge of its internal code or logic, right? So obviously the type of testing that you do that there is on the functional testing. You can do, check all the functions, and then you also do non-functional testing, which include the performance, security, and all that, right? So now the next one is white box. Obviously, again, my analogy, you are looking at something that is white, you can see it, you can see the internal logic, you can see how inside the box is. So that's another thing with white box testing, right? You are testing it, you are seeing the you are testing that software, right? And then you are testing it with the knowledge of its internal code. You know what the internal code, you can see the source code, you have access to it, you understand how it's been written, you understand the logic around it, and then you also know the structure of it, right? So, and then the type of testing you do that is unit testing. Like I said, most often developers do it. And how does that quite suit with developer doing that code and then code review, right? How does it suit with developers? Because developers are the one writing these codes, right? So when they are testing it, they have access to the source code. They have access to all the logic, right? They have access to all the logic. They have access to the structure of the code of that software. They can see the code, right? So when they are testing it, they are looking at the code and then they are testing. So that is when unit testing. That's why, as I mentioned earlier, developers are the one that do unit testing. They also do code review, right? So this is how it works in an organization, right? When that story obviously requirement, I want to drill it down so that you see how they relate to each other, right? So going back to our software development lifecycle, right? You go to requirement gathering, right? After requirement gathering, which is the first one, requirement analysis, requirement gathering. So the next one is designing, then coding, building it, right? So once the developers are building it, once they are done building it, right? They do their unit testing, and when they are doing their unit testing, they are looking at the code they are building. They are testing all the components. They are testing the logic. They are testing all the method, different method, all the logic, the functionality, right? So they are looking at it. They have assets. What kind of testing are they doing? They are doing unit testing, and if they are doing unit testing, and it falls under white box testing because they have access to the code, they have access to the logic, they have access to the structure of it, right? Once they are done, before we start testing, they have something they call code review, right? So in an organization, what they do is that they commit this code they've written into Git, right? Depending on what they use, some of them use Bitbucket, some of them use GitHub, the one that Git, the one you've downloaded, right? Some use Azure Repo because Azure has got its repository. You also be using Azure repository because most of your automated tests will be committing it into the Azure repository. So once they have done that, they will create a PR, what is called pull request. You will be creating pull requests and that will be reviewing your code, right? When you start automated test, they create a PR. So when they've created a PR, they don't just merge their code to the mass and say, yes, the tester come and test, right? Once they create a PR, their fellow developer, sometimes the senior developer will now go and do a code review their code and look at what they've written, right? That is another type of white box testing because their fellow developer is also looking at their code, looking at how the logic is, and ensuring that that makes sense, right? So that is it with types of testing. As you can see, the last one is white box testing, and yes, we've covered it. And then we are now going into what is a bug in software testing, right? What is a bug in software testing? Now, here we'll be discussing what a bug is. We have discussed that before, right? We've talked about when we are talking about, error, defects, and failure. We mentioned that defects is also a bug, right? So now we'll be diving into it just to, water ground to, when we'll start discussing the bug and the bug life cycle and then the components of bugs, right? So now let's look at what is a bug, right? What is a bug? What is a bug, right? So now a bug in software testing, also known as a defect, right? Which refers to unexpected behavior in a software application that deviates from its intended functionality, right? So let's say, for example, you are testing a particular software, right? Let's say you are testing an Amazon website, and we have discovered that something is not quite right. That is, we are unable to log into Amazon to purchase an item, right? This pending issue is preventing us, from actually logging into that website, right? We have entered our correct username, we've entered our correct password, and we are still unable to log in, right? It's a bug. It's a bug. You have to raise it. Let's say, for example, right, we have a website, right, and the website says that, yeah, that the address on the footer, right, should be our company address. And from the requirement, the acceptance criteria, you have the correct address. Let's say the address is somewhere in London, right? So you need to SIP London postcode. It has to be a London address. And you've gone there, you are reviewing it. You are seeing USA, right? It's a bug, right? Let's say, for example, you are meant to see, once you're on the homepage, you need to see the logo on the top left hand side, right? And you come to the website and you're seeing the logo on the top right hand side. It's a bug. You have to report it. It's a defect. It's an unexpected behavior, right? Let's say, so most websites, when you are at any page on that website, you must see the logo, and when you click on the logo, it will redirect you to the landing page, to the homepage, right? And you've navigated to the checkout page and you can't see the logo. It's a bug, right? So what is this bug? Unexpected behavior that deviates from the intended functionality is what a bug. I've gave us instance about what a bug is, right? So yes, that's what a bug is. So we'll move on to components of bugs. Components of bugs. We'll move on to components of bugs, right? So what are the components of bugs? So when we are discussing the component of bugs, it means not what you will see in a bug, but when you have found this unexpected behavior, right? Unexpected behavior. You've seen an unexpected behavior that deviates from the intended functionality, right? You want to raise it. What are the things that you include on those bugs? So not the terms, not the terminology, right? Because the reason why I'm explaining it this way is that you will go for an interview and they say, yeah, have you raised a bug before? And you say yes. What are the components of a bug? Right? You need to understand that when they say what are the components of bugs, the components of bugs are when you have when you have seen this bug, what are the things, and you are trying to raise it? What are the things you need to add on this bug? What are the things you need to include for this bug to make sense, for people, for the developer to actually be able to recreate that bug, to understand what that bug is, right? That is what the component of bug is. And we'll go through the component of bugs, right? The first one is title, right? Once you found a component, once you found a bug, you need to give it a title that makes sense. You need to give it a title that is concise, a title that is concise and descriptive, and it must be a descriptive title that summarizes the nature of that bug, right? You need to give it a title that is concise and descriptive that summarizes the nature of that bug, right? Let's say, for example, you are not able to click on login button, right? And that is a bug you are raising it. You need to give it, when you are raising it, we will show you how to raise a bug on Azure DevOps. But now pay attention to all the components, because once we've shown you how to raise the bug, right, you will now be able to attach all the components whenever you raise a bug, right? Now, I have told you one of the first component that we have is title. And I say when you're raising a bug, you need to give it a concise and descriptive title that summarize that nature of a bug. And like I was saying, I was trying to give an instance. When you find a bug that you can't, when you found that you are testing a website, right? Or an application or software, and you are, let's say, for example, a website, and you're not able to click on the login, and there's a bug. That login is meant to be clickable, right? And you want to give it a title. How would you give that title, right? You can say the login. If it's a login button, you can say the login button is not clickable. It's very, very, anyone that come when the developer sees it or the BA sees it, will know that the login button is not clickable. You can't click on the login button. It's not clickable, right? So that is what it is, right? So the next one that we'll have is the description. So once you've given it a title, you need to give a description. You need to give a detailed description of that bug. You need to include what went wrong. You need to include the expected behavior. You need to include the actual observed behavior. Yes, the actual observed behavior. I've mentioned about when on our first class, we were talking about the actual results and the expected results. And I was mentioning that the actual result is what you have observed, you as a tester, what you have observed that that particular functionality to be. Let me use this login button, for example, again, right? Now, the login button, the expected result, right, is that when you click on the login button, you will see the login field. When you click on the login button, login field, what display, right? Now, and you are clicking that is expected result. Then when you click on it and nothing is happening, the login button is not clickable. What is the actual result? The actual result is what? Login button is not clickable. So note what the expected result is and the actual result. Because when you are raising the bug, right, you would include the reproducible step, right? You include the step that someone else can actually go and then follow that particular step and actually be able to find or to trace the bug you've raised, right? So you need to include that. And the good thing is with Azure DevOps is that if you have written your test case very well, right, and you are running it and it fails, and you are raising bug, you automatically generate a reproducible step for you, right? Well, you have to, when you are running it, you have to add your actual result. But let's say you are creating an independent bug, right? A bug that is not associated to the test case you've written. You need to add the reproducible step. You need to add the description. You need to write it in Gherkin syntax, given when then we'll come into Gherkin syntax by the time we'll start writing our test cases, right? So you need to reproduce it, write it in such a way that, yeah, okay, let me give you an instance. So given I navigate to the URL to PrimeSoft, right? So when I click the login button, right, the expected result is a login button, then login button should login field should display, right? So then this is a kind of description. Then the expected result is login field display, but the actual result is what? Login button not clickable. Have you seen? I'm giving a full description. When I give it to someone or a developer, the developer will be able to come in, right, follow my step and find out that, yeah, oh, the login button is not clickable, and it's a bug because the expected result is that it should be clickable, and then the field should display, the login field should display. So that's a bug right there, and that's a full description of that bug, right? And you need to make it to be, like I've mentioned, it should be easier for a developer to recreate. Recreating that bug is going back, following your step to see that what you are saying is a bug is actually a bug, right? Now, we'll go to the next component, environment details. Environment details. Environment details. So environment details, you need to give information about the environment in which the bug was observed, right? Because sometimes you might be testing a particular functionality on Chrome drive on let's say you are using a Chrome browser, right? And you are seeing something is not functioning properly. When you are testing it on Firefox, it's functioning, right? Or you are testing on a desktop, you're testing a desktop application, right? It's not functioning. When you are testing it on your Windows, right, or a desktop, you are seeing a functionality very well. All the fields, or all the tests are well arranged, right? All the cards are well arranged. But when you are looking at it on your tablet, it's not well arranged, right? Some of them are cutting off. Some of the information are not being displayed as it should, right? And then when you raise that as a bug, because the acceptance criteria may have said that this particular functionality or this particular website, or software should be compatible on both all the browsers and all devices, right? So when you are raising the bug, you should include that, yes, this the bug, the it should include the detail that, yeah, this bug or this particular functionality is not working on so device, right? You need to give information. You need to give information if it's not working on Chrome browser. You need to say it's not working on Chrome browser. That you tested it on Chrome browser and it's not working, right? You need to specify the operating system. The operating system you need to specify. Is it a Windows? Is it an iOS? Right? You need to specify it. If it's a window, you need to mention the window version. If it's Windows 10, if it's Mac OS, we have different Mac version. You need to specify which one, right? If it's the bug is on browser, you need to specify the kind of browser. You need to specify if it is Chrome browser. You need to specify if it's Firefox. You need to specify if it's on Edge. If it's device, you need to specify the device model. You need to specify all these things, right? Then the next one we'll have is severity and priority. Severity and priority. I think this is the fourth time, if not more, that we mention severity and priority, right? And what is severity? Severity is the impact of the bug on the software functionality, right? The impact on the bug, on impact of the bug on the software functionality. So when you are talking about severity is categorized into critical, major, minor, or cosmetic. So I have raised a bug before, and then when I raised it, and they were asking me what is the severity of that bug, right? So the severity, what is the severity of the bug? You need to know if the severity of that bug is critical. You need to know if it is major. You need to know if it is minor, if it is cosmetics, right? So cosmetics, for example, is, for instance, a test, right? They say, okay, this test will be, the header will be bold, for example, right? Or when you click on the button, when you want to click on the button, yeah, the button should be responsive. So the button will be blue, but when you want to click on it, it will turn red. And it's blue when you want to click on it, it's still blue, but you can still click it. It's cosmetics. It's cosmetics. It's not, the severity is not major. It's not minor, but it's cosmetics, right? It doesn't impact the functionality. It doesn't impact anything, right? When it is minor, let's say, for example, a spelling mistake, when is that spelling mistake is not critical? Some spelling mistake can be critical. Some spelling mistake can be major, right? Or let's say font size could be minor. It could be something that you can do without. The size of a picture, the size of cards, those are minor. So we have major ones. So major ones are the ones that could affect the business, right? When the severity is major, it could affect the business, right? And it need to be fixed. In fact, when a bug is its severity is major, it needs to be fixed, right? Then we'll have critical. These are the important ones. As soon as the that bug is the bug, the category of that bug is critical, or the severity of that bug is critical, right? It needs to be fixed. Example of critical is when users are unable to make payment, or they are trying to make payment and it's failing. Because every business are there to make money. They're in business to make money and to, obviously give values to their users, right? So, but when you are selling a product, you are not able to make, your users are not able to make profit. Your users are not able to make payments, right? It's a critical bug. When let's say, for example, Netflix, when their login functionality is not functioning properly, it's a critical bug because users want to log in and, watch movie. It's critical. When you are trying to log into YouTube and no video is coming up, it's a critical bug, right? So that's when you will say the severity is what? Critical, right? Then the next one is priority, right? Priority is the urgency with which that bug needs to be fixed. And it could be categorized as high, as medium, and as low, right? So when the priority is low, right? Developers, the developing team are not in a hurry to test it because the priority is low. They are not in a hurry to test it. They can say, okay, fine, we've taken note of the bug. Let's put it in the backlog for the next sprint, right? But when the priority is medium, they will begin to consider it. They begin to check if anyone has the capacity to fix the bug, right? When it is high, it's urgent. They call it P1, right? The priority is high, especially when it has high priority and the severity is critical. Everybody will need to leave what they are doing and they will need to ensure that they fix that bug. So that is when you raise a bug, right? You need to know if it is. You need to understand the severity, and you also need to understand the priority and assign it, right? So the next one we'll be talking about is expected and actual results. I've mentioned that briefly, right? When you are writing your step to reproduce, your reproducible step, you need to attach your expected and what actual results, right? And I've told you the expected result is what it's expected to, the way that particular functionality is expected to function. And the actual result is what you are seeing it as, right? And then the last but not the least is you have to attach screenshots. You need to attach screenshots. You need to attach screenshot. Once you see that bug, you need to attach it. And the screenshot could either come as, as a file, right? As a screenshot. Sometimes you can need to do a video, right? That illustrate the bug or its impact, right? Attachment can significantly aid the developers in understanding, addressing the issue. Sometimes you can take screenshot, they won't understand it. They don't know what you're talking about, right? But when you do a video, most often I do it in my place of work, right? Once I'm trying to, attach screenshot, sometimes screenshot will not just, will not capture what the way that particular software is behaving. So you need to do a video, record it, perform that particular function so they will understand. It helps them to understand. So these are the components of bugs, the 6 components of bugs, right? When you are asked this question in an interview, what are the components of bug? You need to mention these six items that we've mentioned here. The title, you need to these 6 items we'll mention here. You need to tell them that components of bugs include the title, right? This is when you explain, give a clear and concise, title of what the bug is, right? Then you give description, which could include steps to reproduce. Then the environment where you are testing that bug, right? You need to assign severity and priority, and then you need to ensure that you put your expected and actual, and then you need to do your attachment, which is your screenshot, files, video, and so on and so forth, right? So these are components of bugs. So now that we've understand the components of bugs, right? So what is the next step? So we'll now go into defect lifecycle. Don't forget that they say defect is the same as bugs. So when a defect is raised, right? So when you are testing, let me reiterate again. I also want to link it because I like to link it so that it will make sense, right? Let's say, for example, the business analyst going through software development lifecycle again. Business analyst has elicited requirements, and the design team has done their designing. The developers has built their own, write their code and do the development part of things, and then you are now testing it, right? In the process of testing it, when you must have raised a bug or you find out that a particular functionality is not working as expected, right? It's a defect and you've raised it. So when you are raising it, you need to ensure that the 6 components of bug that we've mentioned are included in it, right? Which, like I've mentioned before, it includes the title, right? It includes the description, it includes the environment, it includes the severity and priority, the expected and actual result, and then your attachment, the screenshot. Once you have done this, right, you've now raised a bug. That bug will now go through a life cycle, right? And the life cycle is what we're going to explain now, right? So what is defect life cycle? A defect life cycle is a systematic process that describes the stages defect goes through from identification to resolution, right? Within the software development and testing environment, right? This is also known as bug life cycle. Do not forget that I told you that defect is bug, right? Defect, another name for bug is defect. Defect is bug. So, like I said, once you have found this bug, right? You've added all the components of it, right? Now it goes through a life cycle. It goes through a life cycle, and that life cycle is what we are going to discuss. Like I've told you, the defect life cycle is a process that describes the stages a defect or a bug goes through from the point you identify it to the point it gets resolved. Does that make sense? So what it does is that it helps us to manage and track defects effectively, right? And it ensures that they are addressed in a structured manner. You don't want to raise a bug and nobody remembers it, right? You don't want to do that. You want to raise a bug and follow the bug life cycle and follow the bug lifecycle, and then trace it until it get resolved, right? And know that not all the bug you raise could actually be a bug. Some of them might not be a bug. Some of them, someone may have, raised that before you, and it's a duplicate bug. Do you get? Some of them, developer might want to reproduce it and say, no, this is not actually a bug, right? Some of them could actually be a bug. Some of them might be low priority and low severity. They don't want to do it, fix it at that time. So this bug life cycle is what will help us understand the process of how the bugs have been, traced, right? So let's go into the defect lifecycle states, right? All the process that bug goes through, right? So the first one is new. A defect has, when the stages, the first one is new, right? This is when you've raised a bug and logged into the system, right? You find a bug, you've raised it, by raising it and logging it to the system by adding all the components of that bug, right? Then the next stage is open. The defect is acknowledged and accepted by the developing team for resolution, right? So they've said, okay, fine. Remember, when you've seen it, you've raised it, you've logged that bug, you've added all the components, right? So the development team will say, okay, fine, we've seen that, right? It's open, we've seen it, we've accepted it. They've seen all the components, all the attachments you've added, your step to reproduce, they've seen your expected and their true behavior, right? Then they assign it the value of open, right? So what happens is they assign it to someone. A member of the development team has been assigned to it, right? So sometimes one of the developer, they will say, oh yeah, you look into this bug, right? The status of that bug becomes what's assigned. So the next one is fixed, right? So when it's fixed, the developer, right, has gone in, right, and see what the bug is, has fixed the bug, and then deploy that bug into your testing environment, right? And then tell you that yes, this bug has been fixed and ready for you to go and retest it, right? So after it has been fixed, what you do is what? You go and retest it, right? This is now when you go and execute that test case. You execute your test case again, check, retest it. After testing it, you will ensure that, okay, that this is been fixed, that bug is no longer there. Let's say, for example, the login is no longer, the login functionality that wasn't clickable is not clickable, right? Yes, it's resolved. But what if it's not resolved? You have to reopen it. You have to go back to the developer and say, no, this bug that I fixed, this bug that you fixed, I'm retesting it, and the bug is still there. The login functionality is still not clickable. It's still not clickable, right? So they will go back and then have a look at it and refix it, right? So, but if it is tested and everything is okay, right, you will close it, right? That's when you have closed. The defect is closed when it is successfully fixed, retested, verified without any issue. But when it is when you are retesting it and it's not resolved, you have to reopen it. That's when reopen it is. What is duplicate? Duplicate is when you raise the bug and someone else has already raised it. So you have two bugs that is that is the same, right? Someone has logged in that has imputed into the system that login functionality is not working, and you've seen it again and you've added it to the system. What happens? It will be deleted. One will be deleted, right? What of rejected? Rejected is when you raise a bug, right, and they've gone and it's not really a bug, they will reject it, right? So not all bug that you raise will be a bug, right? They will go and reject it. So now let's go to the defect life cycle. These are all the states. So we'll now go into a diagram so I will explain to you how it's been, how it's been done. And this defect life cycle, you will be able to understand, you should be able to understand it and explain it to recruiters because interviewers usually ask this an interview question. Can you run me through defect life cycle? Right? So you do not need to cram this, you need to understand it, right? Because you'll be raising bugs, right? So how do you explain defect life cycle? So I've explained what all these states are, right? But this is how they flow. So I will explain this diagram so you understand it. So now you are testing a particular website or software, right? You've realized that a particular functionality, login, for example, login button is not working as expected, right? So you've raised it. It's new. Remember, new is when you've found a bug, you've raised it, you've logged it into the system, you've included all the components of it, right? Remember the 6 components of bug. You've included all the 6 components of bug, right? So when you have raised it, right, what happens? The status change to open, right? The the development team will acknowledge, will say, yes, we've seen everything, right? They're acknowledging it, right? So what do they do for an open um, bug, right? What they do is now they will go and check, is it a duplicate bug, right? Once it's open, when they acknowledge it, right, they will check, is it a duplicate bug? If it's a duplicate bug, what happened? They will what? Delete one of it, right? They will also go and follow your reproducible steps, right? And check if it's actually a bug. If it's not a bug, they will reject it, right? And that ticket gets closed, they will close the bug, right? Now, the next thing they will do, if it's actually a bug, right? The next thing they will have to have a look is, remember when you raise the bug, one of the components is you assign priority, you assign severity and priority, right? They will not go and look at if it's priority. If it has, they will look at the severity and the priority. If it's of high priority, they work on it, they will assign it. But if it is low priority and is low severity, what they do, they defer it to the next sprint, right? This is this. So, but when it is high priority, high severity, what do? They assign it. They assign it to a particular developer, they will go and fix it, right? So once they assign it, that developer will what? Fix it, work on it, fix it. Once the developer has fixed it, what you will do is you retest it, right? I hope you're following. So once you've retested it, right? If it fails, you reopen it. Once you reopen it, it goes back to reassign, fix, retest. If you fail again, it go back. It will keep going back until you've tested it and it passed. That login is not clickable. You will now verify it, right? And then you will close it, right? This is what Defect Lifecycle is. It's very easy. Once you find the bug, it's assigned the status of new, right? When it's open, they check, is it a duplicate bug? If it's not a duplicate bug, right, they will go and check if it's actually a bug. If it's actually a bug, they will now check the severity and priority. If it has high priority and high severity, they will not assign it. The developer will fix it. You will retest it. If it fails, you reopen it, and they will reassign it. If they fix it, you retest it. If it passed, you verify it. It's passed. Everything is okay. You will now close, right? That is bug life cycle or defect life cycle, right? So next we'll go to defect priorities. Defect priorities, right? So we've mentioned defect, what a defect priorities is, right? So what does defect priority? I know I briefly mentioned it, what defect priority is. So now we want to look at it in depth, right? In depth, right? So now defect priority refers to the level of importance, right? When you are saying something is priority, that means that thing is important or is urgent. So that's what defect is, right? Like I said to you, if it has low priority, right, they will say, oh yeah, we'll move it to the next sprint, we'll do it later. If it has high priority, that means it's urgent, they need to quickly do it. So it refers to the level of importance or urgent assigned to a reported defect within software development and testing processes, right? Prioritizing defects helps the development and testing team focus their efforts on addressing the most critical issues first, right? The prioritization of defects is typically based on the impact a defect has on the system, right? So I've mentioned it before. I've told us that it could be either be cosmetic, it could be minor, it could be, major, right? So these are it. So let's go to, like I said, the priority could be low. Sorry, I've said the priority could be low, it could be medium, it could be high, and it could be critical, right? So let's go to the next page. Defect priorities, right? So we have low priority, and low priority is when it has minimal impact on the system and can be delayed until more important fixes are completed, right? So when the priority is low, you do not need to rush, right? You have to wait. They can put it to the next sprints, right? Because it's just this is low. We are not in a hurry to do it. It has no major impact on the system, right? Or the software. So the next one is medium priority, right? So the medium priority defect has a noticeable impact on the system and should be fixed in subsequent build. Let's say, for example, they are building something. If they are building a particular feature, right, and then you report a bug that has low priority, they won't be in a hurry to fix it. They will say, okay, put it in a backlog. We'll revisit it in our next sprint. But when it's medium, right, they could say, okay, fine, let's leave it for okay, I mean, when developers, when they are done working on what they are working on, they could have a look at it, right? So that is what medium priority is. When the priority is high, right, the defect has significant impact on the system functionality and should be fixed immediately, right? That is when they say, oh yeah, the priority is high, it's high priority, right? We need to fix it immediately, right? They jump into it and they will start fixing. But when the priority is critical, right, the critical defect has severe impact on the system. So it could cause the system to fail, right? So what happened? It has to be fixed immediately. You leave everything you are doing. The developers will leave everything. They usually call it a hot fix, right? They have to leave everything. They have to test it. They have to build it, and it has to go live immediately, right? Because it could be that it has logged, all the users out. The users can have access. You can imagine you are trying to access your bank, your right, you're trying to check, your account balance. You're not able to access, your banking app, right? So that can be very frustrating. That sort of thing is what we call high priority. It has to be fixed immediately, right? So now after that, we'll go to defect severity. We'll go to defect severity. So this is where when we are talking about the severity, right? Defect severity refers to the degree of impact a defect has on a system functionality or the overall user experience, right? So the severity level helps prioritize the resolution of defect based on their potential impact. So as you can see, they sound like two different things, but they are interrelated, right? They depend on each other, right? If the priority is high, that means the severity, right, will be high. The impact that it has on the system is high. So that means it's high. It's of high impact, right? It has high impact on the system, right? So let's look at the level of severity. We'll have low severity, like I said, on the priority. It has minimal impact on the system, right? That is when it's include a cosmetic or a minor, right? Inconveniences on the system. It has minor impact, right? It doesn't stop anything. It's not a showstopper, right? So if it is medium severity, it has moderate severity, that which is a moderate severity defect, will have, just like priority, will have a noticeable impact on the system, but they are not crucial, right? They can cause some, let's say for example, it takes time, when you are trying to load the page, they keep buffering, it takes time to load, basically, right? It has a minimal, impact, right? It's not like it's minimal impact, but it's moderate impact, if I want to put it that way. So when you go to high severity, like the high priority, the defects, the defects significantly impact the system functionality, right? But do not render it completely unusable. So obviously the users can still use that particular software, right? They can use it, but the issue is that it could be very slow. You might not be able to, access some of the pages. Logging in becomes very difficult. Sometimes you're searching, if it's an e-commerce website, you are searching for certain product, you can't find it, So some of those inconveniences, right? Which is not good for the business, right? Because obviously the end user will start losing confidence. They'll start, how we behave when we're using a website that isn't, isn't hasn't met our expectation, basically. So that is what it is. There, the next one is critical severity. Critical severity has a severe impact, right? It can cause the system, to be totally unusable, right? So you might not be able to even log in at all. You might not be able to perform any form of transaction. If it's a banking website, if it's an e-commerce website, you are not even able to add any of your product you want to buy to the cart. If it's a billing company or a billing software, you are not able to see how much of electricity or gas you are consuming in a day. You can't even generate your bill. You don't know what is happening, basically, right? So these are the severity, critical severity, right? So, and that is where we'll draw the line for the night. Now we'll have time for question and answer.